Hi there, this is Mr. Delavat, your physics teacher. So today we continue on mathematics in alternate level physics, part 8. So we talk about part 8 today and we're focusing on proportions. And in physics, you always come across statement like the force is directly proportional to mass, the force is directly proportional to acceleration, that voltage is directly proportional to current. You get statements like that, and they always ask you, how does this person relate to this other? Or what are the factors that determine, for example, factors that determine um, um, the factors that determine the resistance of um, of a material or of a wire. So we talk about the length, the cross-sectional area, the resistivity. So what are the factors that affect the speed of sound? And when they'll say, okay, for example, wind. When the wind is there's a lot of wind, the speed of sound reduces, or there's a direct proportion, or is they always say it's directly proportional or it's inversely proportional. So what do they mean by those words? When they say the speed is inversely proportional to this, the sound is inversely proportional to this, the resistance is inversely proportional to this. So what do they mean? So that's what we're looking at. So it's very important for you to know. So you have two types of proportion. We have direct proportion and we have indirect proportion. We call inverse proportion, or you have direct proportion or have inverse proportion or indirect proportion. So for direct proportion, the key factor is that an increase in one quantity leads to an increase in another. So if I say the voltage is directly proportional to current, I'm saying that if I increase the voltage, the current increases. If I reduce the voltage, the current reduces. Now, indirect proportion means an increase in one quantity leads to a decrease in another. So it means that if I say A acceleration is inversely proportional. So you see, look at the way they are writing it. A is inversely, so it's 1 on. This sign means proportion. This sign means proportion. So when you say inverse, it means 1 over. When you see direct, it's just like this. So inverse means 1 over that quantity. So if I increase A, I'm reducing M. So there are many different examples that we can see. For example, in physics, we have, let me use red for now. For example, if you come to the formula of pressure equals to force on area, you see, in this case, pressure is direct proportional to force, but pressure is inversely proportional to area. So it means that if I increase this man increases. If I increase this man reduces. So this inverse proportion, and this is what? Direct proportion. The same thing with density. You have density equals m mass on what? On volume. So it means, this means density is directly proportional to mass, but density is inverse proportional to what? On volume. So if I increase the density, I'm reducing the volume. Increasing the density, I'm increasing what? The mass. So those are the different things about proportions, indirect proportions and direct proportions. So you always need to know how to calculate this. At times they always ask you, if I increase, for example, if I increase the pressure by 2, what would be the value of what? The force. If I increase the density by 2, what will be the value of the mass? Now if I increase the acceleration by 2, what will be the value of the mass? So those are things that you need to learn how to calculate in physics. So now when we talk about direct proportion, for example, so you're saying that V is direct proportional to I in this case. So what we are trying to say is that we are saying that V is equal to a constant times of I. Now, if you take E, if you make K this constant, this K is a constant. So if you make this K the subject, so what do? You draw lines and you take this I this way below the line. You have V on I equals to K. This constant means that if I take V on I, the value is the same. Whatever I divide it, it remains the same. So it means that you have V1 on I1, it will be same as V2 on I2, it's same as V3 on I3, and so on, so infinity to infinity. So if they ask you now, what is the value of voltage? The value of voltage initially was 2. Let me put it that way, was 2 volt. What now will be the value of voltage now if the current, or they can say that the value of voltage was what will be the value of current if the value of voltage now is what is, if the value of voltage is 2, what will be now the value of current? So normally in solving such questions, you have to understand first is what you have to understand, it's this proportionality. This you have to have this understanding that V1 on I1 is equal to V2 on I2. So if my V increases, my I also what increases. So my value increased by 2, that means that I also has increased by 2. So that the answer also be 2 amperes. But how do you, like, if you want to do mathematics, how do you do that? So you say, okay, my V1, assume initially V1 is V and I1 is A. Sorry, I1 is I, sorry. So what you do now, you put now V over I, you use this formula, using this, equals now what's the new value now? Was 2 volt over I2. That's what you're looking for. Now you have to now cross what? Multiply. You have to cross multiply. So you have now your I2 will be equal to times V will be equal to 2V times I. So it's variable side by V, this one cancels this, and your answer will be left with I2 equals to 2I, meaning that my current at the moment, the current at the moment is 2 times the initial value. So if my initial value was 2, now the present value, the current value now will be 2 times 2, which is 4. So that's how you do the calculations at the time, right? I'll take it over again. When you talk about direct proportion, we say increase in one quantity leads to an increase in another. So it means that V is direct proportional to I. So this is how I write it. So it means if I increase V, I increase I. I'll look at an example like P is equal to F on A. P is direct proportional to F. That's the direct proportion. If I increase P, I increase F. Density is equal to mass on volume. It means that density is direct proportional to mass. If you increase the mass, you increase the density. So that's it. And so mathematically, we write it like V is direct proportion is equal to I. So this V is equal to constant times I. So you make I the subject of the formula, you have V and I equals, you make K the subject, you have V and I equals to K. And this K is a constant, meaning that V1 on I1 is equal to V2 on I2, equals to V3 on I3, equals to V4 on I4, equals to V5 on I5, till V infinity to on I infinity. So I'm saying that if they give you a equation, okay, the voltage has been increased by 2, what now will also be the value of the current? If the value of the voltage has increased by 2, it means that the current by direct proportion, the current value has also increased by 2. But how do you know mathematically? That's if we assume that initially V1 is equal to V, V1 equals to V, and I1 equals to I. If you put it back in this formula, so you put V on I, this is V on I equals to the new value now, which is 2 volt over I2. I2 is what you're looking for, this one. If you do cross multiplication, you see I2 times V, which is this, is equal to 2V, which is this, times this I. And now, for you to make I to subject, you take this one back to the side. So you you divide both sides by V. This one cancels this. So you left this one cancels this. So you're left with I2 equals to 2I. Which this I now is the initial current, meaning that our current value will be 2 times the initial value. That's meant by direct proportion. Now, if you talk about indirect proportion, what do you mean? As you said, is the main things are increase in one leads to a decrease in one. And say you write it like A is 1 over that value. So it means that if you are saying A will be equal to a certain constant times 1 on M. That's what I mean. So it says that if A is equal to, so it will be same as K on M. If you want to make K the subject, we have A times M is equal to what? K. It's the same thing with the other. So we have A1 times M1 is equal to A2 times M2 is equal to A3 times M3, and so on to infinity. The same thing you can write with this one. This one can become, what do you have? You can have P1 times A1 equal to P2 times A2 equals to P3 times A3, and so on. The same thing can happen with the one of density and volume. You can have rho 1 times V1 equals to rho 2 times V2 equals to rho 3 times V3, and so on. So every form equation that is inverse proportion, this how it's written. And they can ask you, if I increase the density by 2, for example, what will be the new value now of the volume? Right, because you said density is inversely proportional to volume. So if you increase the volume, you're reducing what? The density. So if I increase, if the volume now is 2, is 2 times the previous value, what now will be the volume, the density, the current density now of the system? So if I say, okay, the initial volume, see the pen. Okay, you see now, the initial volume was, initial density 1 was rho, initial volume was V. Now they are saying that the volume now has increased by 2, right? Has increased by 2. So V2 now is 2V1. So now, how do you do it? You come now, put it back here in this equation. So you have rho 1, you substitute. Where you have rho 1, you put what? Rho. So rho, which is here. So you put this one here. This one, you can put it here. So where you see V1, you put V. So you put V is equal to rho 2. We are looking for it, we don't know. V2. So where you have V2, you put this one. Because you have 2V1, right? And our V1 was V, so it will be 2. So you divide both sides. So you take this 2V, you bring them this way. Be rho V over 2V1 equals to rho 2, right? But this V1 and V are the same because we said here that V1 is equal to V, so this man cancels this. So you're left with rho on 2 equals to what? Rho 2. So what does that tell you? Means that if I increase the volume by 2, Means I'm reducing the density by what? By half. So means that this half means I'm reducing the density by half. So if you increase by 2, you're reducing by half. If I increase by 3, I'm reducing the density by 1/3, by 3. So that's what it's saying. And so it goes the same with all other quantities. So I just want you to take it back, like you go under your notes under the topic of density, topic of pressure, topic of current, where you talk about factors affecting these different quantities. Look how they relate. Try to think about it. They said this is my direct proportional to this. Look at problems out there. If you think about the problems, come to my comment section, post them there, and let's see how we can reason together and how to solve them. So that, because if your understanding of this is very crucial for you to interpret graphs and also interpret certain equations that will come to you, that will come to you. And if you can interpret this, I'll show you A grade is knocking at your door. A grade is knocking at your door. So that's how it is. I hope you've understood. And if you want to do more questions on this, get to the comment section, join the WhatsApp group, and we'll be able to discuss more on this. Thank you so much, and thank you for listening. And whatever problem you have on this, you can post in the comments. I'm going to make a video on this so that you can better understand too. Your understanding, it's my pleasure. I'm so happy if you understand. That's what I mean. Thank you so much, and have a wonderful time.